Hello students, welcome back to today's class on square roots and cube roots. In the previous classes we learned about exponents and powers, and extension to that we are going to focus only on squares, square roots, cubes and cube roots. Right? My name is Avinash and I am a graduate from IIT Kharagpur. Let's continue today's session. So what is exponents and powers, which we have already discussed in the previous classes? Powers are used to represent exactly how many times the number should be used in a multiplication process. How many times the same number should be multiplied to itself, right? For example, I have 5 into 5 into 5. How many times? We are multiplying the same number 3 times. Okay, so 3 into 3 into 3, 1, 2, 3, 4, 5, 5 times. We write as 3 top of that 5, 3 power 5. We read that as 3 power 5 or 3 raised to 5. 3 raised to 5, or simply we said 3 power 5. Okay. 10 into 10 into 10. So we use 10 3 times. We multiplying 10 3 times, so 10 cube. How we read this? 10 cube. Okay. So 10 power 3, we read it as 10 cube. 10 into 10, we write that as 10 power 2, which we read as 10 square. So today our goal is to learn about squares and cubes. Squares and cubes. Okay. So moving ahead, let's try to understand what is a 10 power 9. We already discussed that in the previous classes. 10 power 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how you can simply write 10 power 9. 10 power cube, 3 zeros, 10 power 5, 5 zeros, 10 power 7, 7 zeros, 10 power 9, 9 zeros, 6 cube, 6 into 6 into 6. 6 into 6 is 36. 36 into 6, 6 6 are 36. 6 3 are 18, 19, 20, 21. So that becomes a 216. That becomes a 216. Okay. So 4 cube, 4 into 4 into 4 into 4. 4 4s are 16 into, again 4 4 is 16. So 16 16, maybe 256. Let me check that. 6 6 are 36, 6 1 6 7 8 9 6 1. That becomes 256. Okay. So 256. So this is how you find the values, right? Now, let's try to understand about square roots and cube roots. Before that, let's try to understand about squares and cubes. Then we'll go forward for square roots and cube roots. In today's class, we're going to discuss about squares and cubes. Okay. Express the following numbers as a product of equal factors. Product of equal factors. That means if let's say you have a number 6, and you need to express that as a factors, a product of factors. We can write that as 2 into 3 or 1 into 6, right? 1 into 6, 6 into 1, 2 into 3, 3 into 1. So all these are expressing the same number in terms of its factors, product of factors. Now in the same way, let's try to understand how to write 1. 1 we can write as 1 into 1, the same number being multiplied twice. 2 we can write it as 2. I don't think we can write in any way. Okay, let's try to ignore that. 4 we can write as 2 into 2. 9 we can write as 3 into 3. 16 4 into 4, and 25 5 into 5. Okay, this is how we write all this. 1 into 1 we write as 1 raised to the power 2, or simply we read that as 1 square. We read that as 1 square. 2 into 2, it is a 2 square. 3 into 3, 3 square. 4 into 4, 4 square, and 5 into 5, 5 square, and still continuing, we get 6 square, 7 square, 8 square, whatever the numbers are, right? Okay, so this is how you write a square. For example, I write 10 square, which means that 10 into 10, so which is 100, correct? I have 121, we can write as 11 into 11, which is a 121, which is 11 square. 12 into 12, 144, 13 into 13, 169, okay? The next one you get 144, the next 169, 14 into 14, 15 into 15 is 225, 16 to 16, 256, just now we solved that. So in that way, we have a number, the same number being multiplied. Again, we get that as a square. We read that as a square, okay? The next one we're going to learn about, you might have observed in the given pattern, the numbers are expressed as a product of 2 equal factors. Product of 2 equal factors, just now, right? 100 we express that as 10 into 10. 81, 9 into 9. 64, 8 into 8, right? So those type of numbers, such numbers are called perfect squares. Those numbers are called perfect squares. So now tell me, is 81 a perfect square? Is 81 a perfect square? Yes. Why? 81 can be written as 9 into 9. 81 can be written as 9 into 9, right? In the same way, I will go for 64. 64, is it 6 into 6? No, 8 into 8, okay? Let me write that properly. 64 is 8 into 8. What about 70? Is that a perfect square? 70, no. 70 is not a perfect square because we don't have 7 into 7 or 8 into 8, 9 into 9, never we get 70. That is not a perfect square, okay? So in the same way, let's try to understand more about that. So 9, 3 into 3, yes, that is a perfect square. 49, 7 into 7, 1.44. Carefully, very careful. 1.44 is a 1.2 into 1.2. Is there any difference between the first, second, and third, fourth? 1, 2, and 3, 4. Yes, we have a difference. What is that? We have a perfect integers here, perfect numbers, right? But here we have decimals. All the same thing. 1.44 is 1.2 into 1.2. This is exactly the same what we are discussing for perfect squares. 2.25 can be written as 1.5 into 1.5, right? 6.25 can be written as 2.5 into 2.5 into 2.5. That is 6.25. 2 by 3 into 2 by 3 will get it as 4 by 9. 4 by 9, which we can write as 2 by 3 whole square. 2 times we are multiplying, so in whole square. So all these we are going to discuss a few things about this one, about the difference between the first, second, and the difference between the third and fourth. There is a small difference. What is that? The first two are perfect integers, but not the next two. Okay. So what difference that makes according to that? In the case 1 and 2, we have noticed, right? What we have noticed? The perfect square numbers 9 and 49 are integers. 9 and 49 are integers. Yes, 3 into 3 is 9. 3 into 3 is 9. It's a perfect integer. 7 into 7 is 49. It is a perfect integer, right? So they are perfect squares and integers. The general form of such perfect square number is m equal to n into n. Okay. Same 49 can be written as 7 into 7. Such type of number is a perfect square. Okay. So 100 we can write as 10 into 10. 121 we can write as 11 into 11. So all these are the same perfect numbers, perfect squares. Okay. In the case 3 and 4, where we discussed with decimal values, the perfect square numbers are not integers, hence they are not a square numbers. So again, when we are discussing about squares, we are only discuss about integers. Okay. So the general form of such perfect is square numbers, but these are not square numbers. What we have discussed 1.2 into 1.2 is 1.44, right? We have discussed a couple of examples based on that. Those examples, those numbers which we are we are dealing with fractions or decimals will not come under square numbers. Okay, we need perfect integers for that. Okay, moving ahead. If an integer m is expressed as n square, where n is an integer, then m is a square number or m is a square of m. Okay, so if m can be expressed as n square, for example, 144 can be expressed as 12 square, which is actually 12 into 12. Right, 169, 13 into 13. In that way, if we can express that m as n square, where n is again an integer. Okay, we need to understand that where n is an integer. That's the reason. In the before examples, we have 1.2 into 1.2. We are not considering that as a square numbers. Okay, so we need an integers. Yes, we have such type of numbers, and then we say m is a square of m. 144 is a square of 144 is a square of 12. 169 is a square of 13. 225 is a square of 15. A perfect integer should be there in place of n. Correct. Next. A perfect square. So we are going to learn two things: perfect square and square number. What are these two? A rational number that is equal to the square of another rational number. What is a perfect square? A rational number that is equal to the square of another rational number. Okay. For example, we have the same example. We'll take 225, which is a square of the other number, which is square of the other number, right? So we can say that as a perfect square. Next. But what is a square number? What do you mean by square number? There is a difference between these two. Square number, an integer that is a square of another integer. An integer that is a square of integer. The perfect square, you can have even decimals also, but not in the case of a square number. Square number is perfectly with integers only. Okay. Next. All square numbers are perfect numbers. Yes, that's correct. Okay. All the square numbers means integers. Square numbers means all integers. Okay. So all square numbers are perfect square, but all perfect squares are not square numbers. But all perfect squares, for example, 1.2 into 1.2, it is 1.44. We are not getting any integers here, right? These are not integers, but all perfect squares may not be square numbers, okay? Next one, what else we are going to learn here? 2.25 is a perfect square number. It's a perfect square number because it can be expressed as 1.5 into 1.5. It is not a square of an integer. It is not square of an integer. Okay. Therefore, it is not a square number. Understand, there is a difference between them. It is a perfect square. We are getting 1.5 into 1.5 is 2.25, but they are not integers. So, as they are not integers, we should not keep them as a square number. Whenever you read that square number, you should try to understand that it is only reserved for integers. That word square number, that term square number is only to be used when you have integers. It's only to be used when there is a integers. Okay. So in the same way, 2.25, we can go with any other example. For example, 2.2 into 2, right? Or 2.1, 2.1. Maybe, I'm not exactly sure. Maybe 4.41. Once again, please check that. 4.41 is a perfect square number, but it is not a square number. It is not a square number. Understand, there is a difference between these two. For a square number, you should always have an integer with you. Okay, what else? Properties of a square numbers. Let's try to understand a few properties about that. Observe the digits in the unit place of the square numbers. Okay, observe the digits in the units place of a square number. For example, if you go for 1 into 1, we get the units digit as 1. 2 into 2 is 4. 3 into 3 is 9. 4 into 4 is 16, where the units digit is 6. 5 into 5 is 25, the units digit is 5. 6 into 6 is 36, 6. 7 into 7 is 49, 9. 8 into 8 is 81, 64, we are having 4 again. 9 into 9 is 81, 1 again. So 10 into 10, we get 0 at the end, that is 100. So once carefully observe what all units digits we are having here. We have a 0, yes, 10 into 10, 20 into 20, 30 into 30 will get 0. We get 1 we get either 1 into 1 or 9 into 9. So we get 1 as units digit of a square. Do we get 2 anywhere? No. Do we get 3? No. Do we get 4? Yes, 2 into 2 is 4. So we get 4 here as well as 4 here. Again 25, right? 5 into 5, so we get 5 again. 36, do we get, I mean this is 6. 6 we get 6 into 4 into 4 as well as 6 into 6. So we also get 6 as the ending digit of a square. Do we get 7? No. Do we get 8? No. Do we get 9? Yes. 9 again we'll get at 3 into 3 and 7 into 7. So these are the number, these are the units place where a square number can end with. Okay, we cannot have 2, 3, 4, 5, 6, 7, 8. These 4 digits cannot come as a units digit of a square number. These digits cannot come as a square of a number, right? Square of a number. Whatever number you take, let's say 101 into 101, 101, 102 into 102. 1542 into 1542. You may get some units digits from here, but not from here. You yourself can calculate that. Take any random number, 22 in 22, 23 in 23, 24 in 24, 25 square, 26 square, whatever number you take, your units digit will always end with these numbers 0, 1, 4, 5, 6, 9. Wherever you have 2, 3, 7, 8, you can straightforward say that there is no perfect square for that. There is no square of that. Okay. Next. Properties of square numbers once again. Do you observe all these numbers ends with 0, 1, 4, 5, 6 or 9, 2, 3, 7, 8. These numbers will not come. Okay. At units, none of these end with 2, 3, 7, 8. So what we can say with that? The numbers that have 2, 3, 7 or 8, the numbers that have 2, 3, 7 or 8, in the units place are not perfect squares. The numbers that have 2, 3, 7 or 8 in the units place are not perfect squares, right? Next one. Can we say that all numbers ends with 0, 1, 4, 5, 6 or 9 at unit place are square numbers? Can we say that? For example, I'll give you 25. 25, you know it is a 5 into 5. So yes, it is a perfect square. But what about 35? 35, we cannot express that as square of a number. Not 5 into 5, not 6 into 6, not 7 into 7, whatever number you cannot do that. At most, you can express that to 5 into 7, but these two are not the same numbers, so no, we cannot. So what is the answer? Not all the numbers ending with 0, 1, 4, 5, 6, 9 are perfect numbers, are perfect square numbers. Not all, only few. But if it is a square number, definitely it should end with these 6 digits. 0, 1, 4, 5, 6, 9, no other number. I'll give you a big number, okay. 1, 4, 2, 3, 5, 6, 9, 4, 1, 0, 2. Now my question is this number a perfect square? Is a square number? Answer is no. Why? Why? Because the last unit digit is ending with 2, which cannot happen. The unit digit of any square number cannot end with 2. It should end with 0, 1, 4, 5, 6 or 9. It should end with a 0, 1, 4, 5, 6 or 9. Right. The next one. Write the squares of 1, 9, 11, 19, 21. Okay. So 1 square, 1 into 1 is 1. 9 square, 9 into 9 is 81. 11 square, 11 into 11 is 121. 19 square, what is 19 into 19? 9 9s are 81, 9 1s 9. 9 plus 8 is 17. Again it is 19, so it is 1, 16, 361. That becomes a 361. 19 into 19 becomes 361. 21 square, which is 21 and 21, which is a 441. So carefully observe what's happening here. Units digits of every number 1, 9, 11, 19, 21, all these numbers are ending with 1. Okay. So 1, 11, 21, 31, 41, 51. So all these squares will definitely end with number 1 as well as 9, 19, 29, 39, 49. So all these number squares will also end up with units digit as 1. Okay, that whenever you see a perfect square ending with 1, you can directly see either the number will have 1 or 9 in the units place. Right, it's a very straightforward, no need to learn anything. It's a basic mathematics you can understand with examples. Correct? A very beautiful approach. The next one, if a number has 4 or 6 in the units place, then the units digit in the square is always 6. Okay, so 14 into 14, I don't know, whatever it is, the unit digit is 6, so it is 196. Okay, 16 into 16, it is a 256. 4 into 4, it is 16. 6 into 6, it is 36. So you can see all the units digits are the same. So whenever you have 4 or 6 as the number, the square of that number will always be 6. Right? You can take any other example, no problem for that. Let's go for one more. So which of the following have 1 in its units place? Which of the following has a 1 in its units place? So there is some printing mistake. It's not exactly 1. It should be square. 126 square, 192 square. Which of the following have 1 in its units place? Okay. So there is some mistake here. Maybe 126 square, 179 square, 281 square, and 3632 square. Okay. Even the same thing that goes ahead. 116 square, 228 square, 324 square, and 363 square. Okay. So based on the units digit, you can directly say that which number. Okay. Based on the units digit, we can say that which number will be in its units place. Right. The next one, that I will come back to that in the next class once again. So yes, so we have some patterns that we need to fill. A very beautiful approach, you can see. 1 is 1 plus 1. 1 is just 1. 1 plus 3 will give you 4, which is 2 square. 1 plus 3 plus 5, careful observe, we are just adding odd numbers. So 1 plus 3 plus 5, 3 square. 1 plus 3 plus 5 plus 7, we are adding 4 numbers, so 4 square. The first 5 odd numbers, 5 square. The next 6 odd numbers will give you 6 square, which is 36. Next 7 numbers, 1, 2, 3, 4, 5, 6, 7. 7 becomes 49, which is this one is 6 square, and this one is a 7 square. That is how you can try to write like this. Okay, if you add 10 odd numbers, you can say that it is a 10 square. 11 odd numbers, it is 11 square. But always you should start with the number 1. Okay, there are a lot of more beautiful patterns like this that we're going to cover in next class. A very logic oriented questions are there, which we'll understand, and then we'll try to solve it in the next class. Okay, so thank you so much, students. Stay tuned to get the next lecture. Thank you.